Alrighty, so good morning. We've made it to week 3, looking at day 5 today. We're going to be starting on Charles's Law. Before you should have watched this video, you should have checked your homework on Boyle's Law from up above, so make sure you check that if you haven't already. And then after this video, you will have some homework today. Just before we get started today, I wanted to go over a couple things again. Reminders. You do have your final project that was listed up in the week previous. Make sure you take a look at that. Start deciding on a project. Make sure you reach out if you have any questions. And just another reminder that your topic selection, this Google form is due by the end of the week this week. So make sure you get that turned in. Another thing, the lessons moving forward are going to be a little shorter. The purpose for that is to give you time built into each workday to work on that project. So today's lesson will probably only take 30 or so minutes for you to watch the video and do the homework. And then that remainder 30 minutes of class time, make sure you're spending time working on your project during that time. So one more thing before we get started. Next week, I do want to let you know we're going to be moving into something a little different, doing like a lab-based setting online, but you will also have a quiz at the end of next week on the 3 laws we've talked about so far. So Boyle's Law and Charles' Law, which we're going to talk about today, and then we're also going to learn about Gay-Lussac's Law on later this week, so make sure you understand those 3 things for that quiz, and also your temperature, pressure conversions, as those will be on there as well. So if you have any questions about that, make sure you comment into our Zoom meeting this week so you are ready for the quiz come next week. So let us get started. Let me switch pages here and start this presentation. So, like I said, we're going to be talking about Charles's Law today. All you will need today is that same note sheet that we've been working on that we started last week on temperature and Boyle's Law, and then you will also need a calculator again today. Your job is to apply your knowledge about Charles's Law just to some more practice problems, just like we did last week with Boyle's Law. It's going to be basically the same setup, but just with a different equation. So, Charles's Law. Charles's Law states that the volume of a gas varies directly to the temperature in kelvins. So again, looking at volume, just like we did with Boyle's Law, how much space something takes up. But instead of pressure, we're going to be looking at temperature today. And we all know what temperature is. It's how warm or cold something is. But it uses the term kelvins, and that's something we haven't quite talked about a little. I introduced it to you when we talked about temperature conversions, but we haven't used them directly in any practice problems, so we're going to get that today. So, what is a Kelvin? So, other than that, Charles' Law also varies directly. So, we talked about inversely last week. This type of law is a direct correlation, so it means that they're the same. As one thing is increasing, the other is also increasing. As we go through the practice problem today, keep this in mind so that you can check your work as you are doing the problems. If one of the volumes goes up, is the temperature going up? Is the temperature going down? Is the volume going down? So again, we have our graphical representation. You can see that as temperature is increasing, our volume is increasing as the temperature does. This graph could also go the other direction, so as volume decreases, temperature decreases as well. And again, I have a new formula for you, and that formula is V1 over T1 equals V2 over T2. Where of course V is still volume, so volume initial is our V1 over T1, our temperature initial, equals our volume second or our volume final over our temperature final. So this is very similar to Boyle's Law, just a little bit different setup. We're dividing instead of multiplying, which this might get a little trickier when solving the actual equation, but it's still not going to be too difficult. It's a lot of plugging and chugging. So with that, let's go into our first practice problem. A sample of neon gas occupies a volume of 752 milliliters at 25 degrees Celsius. What volume will the gas occupy at 50 degrees Celsius if the pressure remains constant? So let's hop over to our whiteboard and solve that together. So let us remember what equation we are using. We are using, let me find where I'm at, V1 over T1 equals V2 over T2. As we read the problems, just like we did with Boyle's Law, our first step is going to be to list our variables. So we have V1. In the problem, it tells us a sample of neon gas occupies a volume of 752 milliliters at 25 degrees Celsius. So our temperature one is 25 degrees Celsius. It then asks us what volume will the gas occupy at 50 degrees Celsius. So our V2 is unknown. That is what we're looking for. And our T2, it tells us, is 50 degrees Celsius. Just like with Boyle's Law, as long as your initial unit and your final unit are the same, you do not need to convert anything. So because we're in Celsius and Celsius, we don't need to change anything about that. So let's plug in our numbers. We will have 752 divided by 25 equals x over 50. 752 divided by 25 will give us 30.08. And this will be equal to x over 50 still. I want to remind you that when something is on the bottom, to get rid of it, we need to do the opposite. So because we're dividing here, we need to multiply by 50 on each side. And when we multiply by 50 on each side, we will get x equals 1,504. And remember, we're measuring that in milliliters because that's what our volume was. Now I want you to think about this answer for a second. Remember that volume and temperature are varying directly. So as one increases, the other will decrease. So notice our temperature is increasing, which means our volume has to increase. And we can notice that we started at 752 and increased to 1,504. So we went along with the rule. That's one easy way to check your work, is one thing is increasing, the other will increase also. So you think you at least know you're on the right track. So that is the only practice problem I am going to go over today. Just as, again, these are just plug and chug problems. Just a friendly reminder, if you need extra help when going over these problems, when you go to do your homework right after this video, make sure you go back up to the online work overview section of Google Classroom and click on the support videos tab. In that support videos tab, there's a bunch of extra videos there to help you out if you get stuck, extra practice problems to go over. And again, you all have access to YouTube. There's thousands of videos that go over these there. So make sure you visit that. So back to where we are at today. Once you're done with this video, remember you do have the homework right underneath here for Charles' Law. This homework is going to be just like the one for Boyle's Law. So when you click on that, it'll bring up this page. You're going to visit that same website that you did last time. We're going to go through some important takeaways. It talks about Kelvin again. I know I didn't talk about that too much in the video, so you're going to need to depend on the reading to figure that out. You're going to do some temperature conversions and then just a couple practice problems. Something a little different about this homework, I'm giving you one practice problem to do and I'm letting you choose the other two. Please make sure that when you turn in your homework, I can clearly see what those two you chose were. Write out the problem and solve them. Don't just give me an answer. Make sure you're writing out the problem that you solved. And let me know if you have questions finding those practice problems and if they're not working for you. So again, make sure you have that homework turned in. by the due date, and that is all. After you're done with that, make sure you spend some time on your project, give some thought into that, and make sure you reach out if you have any questions or concerns. Have a good day, guys.